For number 1, the advertising expenditure X and the sales Y in thousands of pesos for a small retail business in the first 8 years in operation are shown in the table below. So in this word problem, we will find the regression line that will predict the sales, and then B, on average for each additional $1,000 spent on advertising, how does the revenue change? Explain. And for letter C, estimate the revenue if 2,500 pesos is spent on advertising next year. So the next thing that we are going to do is to compute for the correlation coefficient, or the R, using this formula right here. And since we don't have the exact values to substitute in the formula, we will look for the summation of x, y, x squared, y squared, and xy. We will then proceed to substituting these values to the formula, which gives us R is equals to 0.83. The next thing that we are going to do is to test the significance of R using this formula right here. We will then substitute R and N to their corresponding variables, which is equals to 3.65. In comparing, we find that 3.65 is greater than 2.447, which is the critical value. So there is a significant relationship between the two variables. We will then move on to the regression analysis. So what we're going to do is to compute the values of A and B in the regression equation. Since we have the values to substitute in our regression equation, we will then substitute the values to their corresponding variables. We will then estimate the revenue if 2,500 pesos is spent on advertising next year. So the answer would be Y is equals to 105,169 pesos.
For number 2, we have the following data that shows the age of a car and its average mileage. A. Find the regression line that will predict the average mileage or liter of the car. B. Find the average mileage of the car at age of 10 years. In finding the regression line, the first step is to find the value of the correlation coefficient, which is an important step to proceed in regression analysis. So we have to find the value of x, y, xy, x squared, and y squared. So finding the value, after finding the value, we have the summation of x equals to 21, summation of y equals to 109.7, summation of xy is equals to 290.3, and summation of x squared is 91, and summation of y squared is equals to 1,775.37. We will compute for R. We will use the regression formula as shown, and then substitute the given to the formula, which we will have the results of negative 0.977, and rounded off, we will have the final results of our R, negative 0.98. So next step, we will have to test the significance of R. We will use the T formula, which is R is multiplied to the square root of n minus 2 divided by 1 minus R squared. Then substitute the given from before. Then we will have the results of negative 11.01. In testing the significance of R, we will compare the computed value and the critical value. So for the critical value, we have to find for the degree of freedom first, which is 5. Then using the T table, this problem is also two-tailed. Then as a result, we have our critical value as 2.571 as shown in the T table. Since our critical value is greater than the computed value, the null is failed to reject. Therefore, there is no relationship between the two variables. For the next step, we have to find the values of the slope and the y-intercept. So A is our y-intercept. We have the formula here, and from our summation, from our given a while ago, we will substitute it in the formula. Then as a result, we have 19.828, or when rounded off, 19.83. So for B, or the slope, we have the formula here. Then we will substitute the given to the formula, then solve. We will have the result of negative 1.385, or when rounded off, we have negative 1.39. So now that we have the results of our A and B, or the slope and y-intercept, we will form the regression line by this solution, or this formula right here. That is our regression line. And to find the average mileage or liter, we will substitute 10 to x right here. Then we will have the result of y equals 5.93. So therefore, the average mileage of the car at age 10 years is 5.93 per liter.
For item number 3, it states here, the table shows the income of a company in the past 8 years. Here we have in 2013, it's 2.2 million. 2014, it's 2.4. 2015 is 2.9. 2016, it's 2.5. 2017, it's 3.1. 2018, that's 3.3. 2019 is 3.6. And 2020 is 3.9. Now, for letter A, find the regression line that will predict the income of the company for a given year. And for letter B, what is the expected income of the company in 2025? First, we have an independent variable of the year and a dependent variable of the income. Next, to solve the significance of R, we use this formula, which will then give us a value of 0.96. Next, we are going to solve for the value of t, and we are going to use this formula. We would have a value of t of 8.4. Then we are going to compare the computed t value to the critical values. Here, 8.4 is greater than 2.447. Next, we're going to state that we reject the null hypothesis. Then we're going to state that there is a significant relationship between the year and income, and the relationship of the two variables exists in the population. Next up, we're going to solve for A and B. To solve A, we're going to use this formula, and we will then get a value of negative 469.93. Then for B, we're going to use this formula, which will give us a result of 0.23. Now here we have the regression line, which is y equals 0.23x plus negative 469.93. Now we're going to solve for the income of the company by 2025. Using the formula, we would receive a 4.973 million for the company by 2025. With this, the expected income of the company by 2025 would be 4.973 million.
So in problem number 4, the data shows the population of the Philippines from 2005 to 2012. So here is our data, the year and the population, and as we know that the year will be the x. So if we sum up all, we have the overall total of 16,068, and our population here will be the y. And if we sum up all, we have 72,497. And to be able to as the first problem in the 4 is find the regression line that will predict the population for any given year. So we will be getting the A and B. So to be able to get the A and B, we will proceed to the other columns here. So as we add up the whole column of x times y and x squared and y squared, we will get this answer. So to be able to find the regression line, as the first problem indicates, so our A will be 300,374.96, and our B will be 1624.48x. So as this will be our y, this will be the phase of our y. So next, as our slope will be 1.45 and our y-intercept will be 2,822.9 and our x will be 2014, we will arrive to the answer of y is equals to 97.4. So letter C, the problem is, based on the actual data, the population of the country in 2015 is about 100 million. So how close is the predicted value to the actual value? So based on my that I have solved, I predict that it will be 80%. So in problem number 5, survey tests on leadership skills and on self-concept were administered to student leaders. Both tests use a 10-point Likert scale with 10 indicating the highest scores for each test. Scores for the student leaders on the test follows here. Here's the data. Student code, self-concept, and leadership skills, and this is the data that we will based on. And in problem number 5, we have a two sets of problem. A, find the regression line that will predict leadership skill if the self-concept score is known, and B, predict the leadership skill of student leader whose self-concept skills is 1.5. So first, our problem first is find what will be our regression line. So to be able to find the regression line, we will use the y is equals to a plus bx. So to be able to find the a, with the given data, we have gathered and substitute the a. So we have this 7.31, 73.1, 518.29 minus 7.1 and 537 over 10, 518.29 minus 7.01 squared. So we will arrive to the answer of 243.299 over 268.89. So our A is 0.9048. So we will so now we will find the B. So here is the B, and as we substitute it in the formula, we have the answer of 245.69 over 268.89, and our B is 0.9137. So as I have said earlier, that regression line will be y is equals to a plus bx. So now with the letter B problem, x is equals to 1.5. That will be the our x, and then as we gather the a and b, we will put the x as the 1.5, and we will arrive to y is equals to 2.2754, and to estimate that, we will get y is equals 2.28, and that will be the answer.